Today's lesson we're going to talk about inverse trig functions. We spent a couple of days graphing just the regular trig functions. Now we're going to talk about inverse trig functions. First, just kind of briefly, I want to remind you what an inverse function is, if you recall from Algebra 2. It's basically where we switch the x and the y values. You remember that? I bet you like for logs and stuff, you'd switch the x and the y and turn it into an exponential and so forth. So inverse, the trig, these are called the inverse trig functions. They are not the reciprocal trig functions. We've already talked about reciprocal trig functions. On the calculator, they look like this. And I really don't like that -1 notation that they use, because we are used to that meaning an exponent. And we are used to that meaning 1 over, aren't we? This is not 1 over sine. This is arc sine. This is the reciprocal of sine. So, excuse me, it is the inverse of sine, not the reciprocal. Okay, it's not flipping it upside down. It's actually physically switching the x's and the y's. So what in the world does that mean? All right, let's talk about that. So we are accustomed, like if we did sine of pi over 6, right? Pi over 6 would be like our x value, right? Sine, that's what's on when we're graphing, that's what's on the x-axis, or the angle measures, right? So sine of pi over 6, we know the unit circle now, right? Sine of pi over 6 is a half. Well, when we are looking at the arc function, the arc sine, and I like to use its name arc sine instead of sine to the -1. Again, I don't really like this notation. I think it's confusing, but we have to be accustomed to it. So when we use arc sine, or sine of -1, then it's basically, I would do arc sine of 1/2, and I would think to myself, where is sine 1/2? And that would be at pi over 6. So see how they basically have simply flipped the x and the y. Now it's a little bit more complicated than that, because functions, to have an inverse function, have to be 1-to-1. Well, the 1-to-1 is, we can verify it with the horizontal line test. I don't know if you're familiar with 1-to-1 functions. So we are, I think, familiar with the vertical line test to test whether it's a function or not, right? We would do a vertical line and we can only touch it once. Well, the 1-to-1 is basically, if we draw a horizontal line, do we only hit it once? And no, right? Sine and cosine, I mean, all those would fail the horizontal line test for 1-to-1. So what we do in a case like that is we restrict them so that if I draw a horizontal line, I won't go through multiple parts of it. I'll just go through a piece. So somebody a long time ago decided where we were going to restrict arc cosine, arc cotangent, arc secant, arc sine, arc tangent, arc cosecant. They decided where we're going to restrict them. It's not for us to decide. Because if I were to switch so this is like a sine graph, right? If I were to switch the x's and the y's, what would happen? See all these x values, which are like, pi over 6 and pi over 2, all those, where they would be up here, right? And we would have a graph that kind of looks like that, right? And that is definitely not a function. That is definitely not a function, right? That's a relation. So the things we're going to be talking about today, I want you to really focus on that these arc guys right here, they have a function hat when they're a function, and then they have a relation hat when they're a relation. There are 2 parts to them. And that's what was getting everyone really confused earlier. They're thinking that, oh my gosh, it's always a function. No, we also talk about it as a relation. So I'm going to try to really specifically tell you when we're talking about these inverse trig functions as a function or as a relation. Okay, so now let's kind of work on the function part, because that's a very restrictive part. On the function part, we can't, that's a relation, it's not a function, so they basically restrict it. They cut it off to where with sine, the domain is -1-to-1. That's normal, right? That would be regular sine's normal range. But look what they've cut off. It only goes from -pi over 2 to pi over 2, which is why if you look at arc sine right here, this arrow only goes from pi over 2 to -pi over 2. because that's the only place the function exists. The relation exists everywhere. The function only exists in these quadrants. I'll pause there for a second to make sure we understand. The function only exists in these three quadrants. The relation exists everywhere. See, this is everywhere. Okay?
So you're only allowed to graph those functions in those specific coordinates?
Yes, when we're talking about the function, that's exactly right. We're only allowed to pull values from those specific quadrants. And so that it basically goes all with this domain and range for them. So let's talk about how this works. So all 6 of the inverse functions, inverse trig functions, all 6 of them are positive in the first quadrant. If it's positive, they're going to be in the first quadrant, period. Okay? If it's negative, I think, well, basically, notice this big blank right here? There's nothing here. This is like no man's land, right? You can't go in the third quadrant for function values. Another word we use for function values are principal values. Principal values are the same thing as the function values, are the same thing as exact values. Okay, very restrictive. There's only one right answer. Only one right answer for function values and principal values. Those are the same thing. Only one right answer. Okay, so let's talk about the one right answer. So if it's positive, the one right answer is going to be in the first quadrant. If the arc function is positive, the one right answer is in the first quadrant. If it's negative, then if it's arc cosine, and I think that makes sense, right? We know cosine is x, right? X is negative over here. If it's arc cosine and arc secant, it's negative over here. I'm going to talk about the cotangent and tangent in a minute. I think those are harder to figure out. If it's arc sine, it's down here in the third quadrant. Arc cosecant, because why? Because sine is y, and y is negative in the bottom of the graph, right? In third and fourth quadrant. So arc sine and arc cosecant are down here. Couple things. Notice how this is out. Not only can I not do function values here, no principal or function values here, I also cannot pass through here. I cannot pass through here to get to the fourth quadrant. I have to go backwards. Notice how we're going backwards. Notice this domain has negative angle measures in it. We're going backwards to get here. So if so arc sine and arc cosecant are here. So I think the harder ones to figure out where their principal values are these two, because it's like, well, you know, I don't know. I'll tell you how I remember. How I remember is I know that cotangent is cosine over sine. And cotangent's numerator is cosine, so it goes with cosine. That's how I remember. And tangent, we know, is sine over cosine. And tangent's numerator is sine, so it goes with sine. That's how I remember which quadrant they belong to. Otherwise, I would not be able to keep it straight. Promise. That's how I have to do it. Maybe you'll come up with a better way to remember that arc cotangent, the principal value, the function value for arc cotangent is in the negative one would be in the second quadrant. The negative arc tangent is in the fourth quadrant. Okay, so that is function values. Now, your calculator is not as smart as you are. Your calculator actually only can give you function values of the inverse trig functions. It cannot give you anything else. It can't give you relation values. Okay, I will show you how to do relation values. We are going to have to find those in the next example, but I will show you. So the calculator is programmed to give function values for the inverse functions, the inverse trig functions. Also, if you notice on your calculator, you only have these buttons, arc sine, arc cosine, arc tangent. You don't have these. So in order to find those, there's a couple of options that you could use. One happens to be this little option over here. So if you're asked to find arc cosecant of 2, or 2 over 1, you can actually take the argument and do the reciprocal of it. Why? Because Cosecant and sine are reciprocals of each other, right? And so if we do the reciprocal of this argument, we could type it in our calculator as sine of 1/2. Okay, so that's one way to do it. Certainly you could say 1 over, arc sine. You can do that too. 1 over arc sine of 2, and that would give you that one too. So just a couple of options for us. Okay, I want to pause here for just a second. I'm hoping that that's kind of sinking in. So we have two hats, if you will, two avenues to take when we're dealing with the inverse functions. And on the next slide, we're going to do some of each. So I'm going to explain each one. So let's go to our second page. Okay. So here it says find the exact value. That's a little clue for function value. It could say find the function value. It could say find the principal value. That means there's one right answer. That's it, just one right answer. There's not an infinite number of answers. There's only one. And it has to do with the little chart on the other page about where they exist, where their function values exist. So we look at the first one, x equals arc cosine of √3/2. We see that this argument is positive. So we know they're all positive in the first quadrant. So this angle would be in the first quadrant. It's cosine, so it would be the longer one, right? Because √3/2 is bigger. So it's this angle measure that we're looking at. We're first quadrant. We rotate this way. And so that would be pi/6, right? So x equals pi/6. So how do we know that's a unit circle value? If you recall, so our points there at the unit circle value would be √3/2 and 1/2. You with me? Since it was √3/2, we know that's x, or cosine, so that's why it's pi/6. Okay, are we okay? I know it's like a shift in the way that we've been thinking. I'm hoping that we know that cosine of pi/2 is √3/2. Excuse me, cosine of pi/6. Cosine of pi/6 is √3/2. Therefore, the arc cosine of √3/2 is pi/6. Okay, see how the inverse function says flip the x and the y. Okay, so let's look at the next one. Okay, so we have arc sine, and arc sine is negative. Which quadrant, and this is a function value, not the relation value, which quadrant is arc sine negative in? It's the fourth quadrant, right? So it's the fourth quadrant, it's down here. When we're in the fourth quadrant and we're dealing with function values, we are only allowed to go backwards. Only allowed to do a backwards rotation. We are not allowed to go through the third quadrant. So we can only go backwards. So we've got to figure out, okay, so what would that angle be where sine would be negative √2/2? And negative 45 or negative pi/4. Okay, so that one would be negative pi/4. Now, are there other ways to write this location? Sure. We've done coterminal angles before, right? We know we did that in Unit 1. There's like an infinite number of ways to write this spot. Right, we could write it as a negative pi/4. We could go all the way around and write it as 7 pi/4. Right, there's lots of ways we can write this spot. But there's only one correct way to write the function value, and that's negative pi/4. Okay, because we're not allowed to like rotate around and around because the domain and range have been restricted. We only have a little bit of it is the function. The rest of it is the relation. Okay, so I'll pause here for just a second. Are we okay? All right. On the next one, this is like a little bit more complex. We work from the inside out. So I'm going to work on this part first. This is not a unit circle value, so I'm going to have to draw a triangle. That's what I have to do. It's not a unit circle value. I have to draw a triangle. So let's think. So it's arc sine, and we know arc sine is negative in the function value, of course, in the fourth quadrant. So we're down here. Okay, so that's our theta. We know sine is what? Opposite over hypotenuse. So opposite over hypotenuse, and the negative, I think we are, the hypotenuse is never negative, so this is the one that's negative. So we do our Pythagorean theorem, and we get root 5. Okay, so this triangle represents this part right here, this whole piece. So basically what they're asking us to do is to do tangent of this triangle, right? Tangent of this triangle, because this has replaced this piece. So we look on the triangle, we find tangent on this triangle. We know tangent is opposite over adjacent. So this is going to be what? Negative 2 over root 5. Okay, we okay with that? Okay, this last one on part number 1, to find the exact value, we are, so some of us were thinking, okay, well, arc sine of sine, they're inverse functions, they should just cancel each other out, right? Well, I mean, sometimes it works really easy like that, but once I find this answer, I'm going to have to take arc sine of it. Does the function arc sine exist at 7 pi over 6? No, it doesn't exist there. That's in the third quadrant. So we can't just cancel the sine, arc sine and sines out and say, oh, the answer is 7 pi over 6. It doesn't work that way. We need to work it just like all the rest. So I'm going to work this piece right here. I know that sine, let's see, 7 pi over 6 is right there, right? 7 pi over 6. So we need to think, what is sine's value at 7 pi over 6? Recall this is negative root 3 over 2, negative 1/2. Right? We know sine is the y. So that's negative 1/2. So now we are replacing this with negative 1/2. Right? That's what the value. Sine of 7 pi over 6 is negative 1/2. Okay? I didn't have to draw a triangle here because it's a unit circle value. If you wanted to draw a triangle, you could. I mean, you could do that, but it's a unit circle value, so I'm just using the unit circles value stuff. I'm not doing a triangle. All right, so now here we have our arc function, arc sine of negative 1/2. Okay, well, we know that arc sine, the function, is only negative here. And I don't really need to do a triangle. Okay, so it's only negative right here. And we know, hopefully we're kind of getting this, we're only allowed to get to the fourth quadrant going backwards for function values, backwards. So we're going backwards, so where would we be? So actually arc sine is at 1/2 is closer up here, right? And so that would be negative pi over 6. Okay. So that is our work with the function version of the inverse functions. Okay? That's function, where it's very restrictive, only one right answer, only one possible quadrant to go to. All right. Now we're going to put the other hat on. We're going to put the relation hat on, because now we're going to look at the inverse functions as a relation, because it's asking for all, not just function values, all the values, including the relation values. So this is a whole different thing, right? Whole different thing. Students were getting really confused earlier, and they were trying to force the function rules on the all. That doesn't work that way. We're either looking at the function and there's one answer, or we're looking at all and there are all answers. There is no thing in between. Nothing in between. Either it's one answer or all answers. Okay, now we're working on all answers. So this we would need a calculator for. So if you have your calculators with you, it'd be great if you would get that out. I'm going to go ahead and pull mine up. So let's see, does it say what? It doesn't say what to be in radian or degree. So of course I love radians. I'm going to be in radians, not degrees. So let's make sure our mode is in radian mode, and mine is. Now, as I was telling you earlier, you are smarter than your calculator. Your calculator only knows how to give the function values. It does not know how to give all. There's no button on here that you can say, I want all, arcsine values. It doesn't know how to do that. So we go ahead and it's right here. See the little arcsine is right above the little blue one. So we hit second sine, and we want arcsine of 0.67. And that gives us 0.734. That's a radian measure. Now, this is positive, so by logic we know we're in the first quadrant, right? But if we are unsure, keep in mind, this is pi over 2, and this is pi, so this is 3.14, right? 3.14 all the way around. Here would be half of 3.14, right? Which is bigger than this. Bigger than 0.7. Half of 3.14 is a bigger number than 0.7, so we know we're in the first quadrant. All right, so let's go there. All right. Okay, so there is one angle measure, and it's 0.734. And let's go ahead and write the first of our general solutions. You should always have two. You should always have two. So we have x equals 0.734 plus 2 pi n. General solutions is the same thing as all. All means general solution. Okay, that's what all means, general solution. Now in the previous class, earlier today, they were just writing this part down, not even this part. And they were thinking that was fine because that's the function value. We're not in function, thinking right now. We're in relation thinking. Relation. Because if this were the function value, we couldn't add 2 pi n to it, right? It would take us out of the function. So this is the relation value. So what this is going to do, it's going to capture this location no matter how many rotations we put on it. Because we're in the relation. Because it's all. So there's another place where sine is positive that your calculator doesn't know about. Right? Where else is sine positive? Where else is y positive? In the second quadrant, right? So we have another angle over here. We have to calculate that angle. We need it. So that's our job. So we have to look at, think about logically, how in the world can I get that number? Well, what if I took pi and took out the 0.374? Wouldn't that give me that angle measure? Pi would be all the way around. So what if I did pi and I took out 0.734? That would give me this rotation, right? So I did that, and it's 2.408. Now this location needs a general solution, right? Because I need all the ways that I'm going to be able to get to this location. I already have all the ways I can get to this location right here. Now I need all the ways I can get to this location. So that's going to be x equals 2.408 plus 2 pi n. Okay, there are my two general solutions. Again, I should have two. Now it's asking for the first three positive values. Well, I already found the first two positive values, right? So x equals 0.734 and 2.408. So now I have to think, well, how am I going to get another positive value? Well, I just need to go back to my general solution, right? I need to add 2 pi to something. Which one would give me the next highest value? Should I add 2 pi to this one, the first solution, or the second one? The first one, right? I should do 0.734 plus 2 pi. Okay, that's going to give me my third and final positive value, and that is 7.017. So my third positive value is 7.017. Okay, so now there are two distinct, if you will, hats that we're going to be wearing with inverse functions. We're either going to be looking at the function, which is highly restrictive, or we're going to be looking at the relation, which is everything. Okay, it's loosey-goosey, it's everything. So please try to keep that in mind as we're working through our daily work, because you're going to have both kinds on there. both kinds of on the daily work. Okay? Yes.
Are we going to have to be responsible for graphing the arc?
We will. We have a lesson on graphing the arc functions. I think it's the next lesson.
Okay.
Yeah, we do. We will be graphing them as well.
This one's just solving.
Yes, this one is just this kind of stuff. It's just solving, finding values and stuff, getting kind of accustomed to them. All right. Anything else?